All right, we're going to get into some properties of exponents, and these are all individually very simple properties, but we've got to understand these really well and at their base, and that way when we apply all of them together later, we can break it down and understand much more difficult expressions. So this is an extremely important property, multiplying powers with the same base. And what's very important here is that they have the same base. All right, so I'm just going to jump to the algebra part here. I have a to the m power and a to the n power. So a to the mth, a to the nth. Kind of sounds funny. But they have the exact same base. They're both a's. So you rewrite the a. Notice I'm not multiplying a times a. I just simply write the base one time, and then I add my exponents. M plus n, it's just m plus n. Now, the a is going to be non-zero. We've talked about bases being non-zero numbers, and m and n are going to be rational numbers, so they can be anything from negatives, positive, fractions, decimals, all sorts of things. So if you look at this first example, we have fractions as our exponents. The bases are exactly the same. They're both 4s. So if you have the same base, rewrite that base one time, and then just simply add your exponents. 1/3 plus 1/3 gives you 2/3. So the simplified form is 4 raised to the 2/3 power. I don't want the answer to this. I just want the simplified form of that expression. This one's a really good one to look at. Both of the bases here are b's. We are multiplying, so that's a good indicator. If it's addition, it's a whole different ballgame. So we're multiplying, and we have bases of b's. And then we have 7 and -4 as our exponents. So rewrite the b one time, and then add your exponents. 7 plus -4 is 3. That's the simplified version, b to the 3rd power. All right, so let's look at this expression. Using that property, we have the same base. Both of these are 12. We are multiplying. And we have a 4 and a 3 for the exponents. So rewrite your base one time, and then add your exponents. 4 plus 3 is 7. It's that simple. When you multiplying powers that have the same base, when it's a multiplication problem and it's the same base, you add your exponents. So look at this one. This one we have -5 as our base for both of these. And there's not a dot there, but they're side by side, so you should know that that alerts you to multiplication. So since we have -5 as the base for both of those, we can write our -5 one time, add our exponents, -2 plus 7, which gives us 5. So -5 to the 5th power is our simplified expression. Not the answer. I don't want to know what the answer is to that. I just want the simplified expression. All right, so now it's your turn. Here's your expression. I'm going to go ahead and give you your answer choices. Make sure you pause the video, go back through those last 2 examples if you need to, look at your notes, and simplify this expression. I don't want the answer, I want the simplified version of this expression. All right, so hopefully you've worked that out and not just writing the answers. That's not going to help you any. The correct answer is C. And all they did to get C was rewrite the base, which was the same, one time, and then added the exponents, 3 plus 6, and that's where the 9 came from.
In this problem, you will multiply powers in algebraic expressions. Part A. What is the simplified form of the expression 4 times z to the 5th power times 9 times z to the -12th power? Start with the original expression. Which parts of the expression can you combine?
Think about what have similar, maybe, vocabulary terms. For example, if I ask you for the coefficient of z to the 5th, you would tell me 4, hopefully. And if I ask you for the coefficient of z to the -12th, you would tell me 9. So 4 and 9 are both coefficients, so they have the same vocabulary terms. So that should give you an indicator that they are similar parts that we could possibly combine.
You can group the coefficients and multiply. You can also write any powers that have the same base with a single exponent.
So always look for coefficients because you can combine those, and look for like bases whenever you're multiplying in an expression and you're trying to simplify.
Use the commutative and associative properties of multiplication to rearrange terms.
Commutative property tells you can change the order. Associative property tells you can change the grouping. So we changed the order and we grouped together our like or common components of this expression.
Now, multiply the coefficients. Add the exponents of powers with the same base. Simplify the exponent. Now, rewrite the expression using a positive exponent.
That last step goes back to our negative exponent definition where you can't have negative exponents in an expression, so you've got to move it to the bottom of the fraction. So the 36 basically becomes your numerator because it doesn't move. It does not have a negative exponent, only the z.
Part B. What is the simplified form of the expression 2 times a times 9 times b to the 4th power times 3 times a squared?
Think about what are the common components. What can I group together that are the same?
Start with the original expression. Use the commutative and associative properties of multiplication to rearrange terms.
So notice they put the coefficients all together, they put the base with a together, and they put the one base that has a b by itself.
Now, multiply the coefficients and write a as a to the 1st power.
The reason it suggests writing a as a to the 1st power is so that you remember that having that a there, that is an understood 1 because that's a to the 1st power. So writing it will eliminate any issues later.
Add the exponents of powers with the same base. Now, simplify the exponent.
And that's your answer. That's the simplified version of that algebraic expression.
Now it's your turn.
All right, so here's your expression. Group together all the common components of this expression and rearrange the order and grouping, commutative and associative properties, to write it in a manner so that you can take each part piece by piece and simplify this expression correctly. Now here's your answer choices, A, B, C, or D. Make sure you pause the video, take a minute, and make sure you simplify this expression. The correct answer to this question is C. And the way they got that was, again, they rearranged the order. They changed where the coefficients and the bases with x's were. They rewrote that x as x to the 1st so they wouldn't forget about the 1. And then they just simplified from there.
In this problem, you'll multiply numbers in scientific notation. What is a simplified form of the quantity 3 times 10 to the 5th power times the quantity 5 times 10 to the negative 12th power?
Now you all have dealt with scientific notation in the past. This is where your A part of scientific notation must be between 1 and can be 1 and 10, but it cannot be 10. So somewhere between 1 and 10, including the 1. And then you always have times 10 to some exponent, and that exponent is going to be some sort of integer, whether it's negative or positive. So what you're going to do with scientific notation now is actually combine the two together using multiplication in this case.
Write the original expression. Which numbers can you group to make the calculation easier?
Again, look for the common components.
Group 3 and 5. Group the powers of 10. Use the commutative and associative properties of multiplication. Multiply. When multiplying powers with the same base, add the exponents. Add the exponents. Write 15 in scientific notation.
Now the reason why we're having to write 15 in scientific notation is because it's not correct form. It has to be between 1 and 10, including 1. So we move the decimal point one more place. So that's where 1.5 comes from, times 10 to the first, because we moved it one place. And then we're going to have to just simplify from there because we're not going to have this 10 to the negative 7 out to the side anymore.
Add the exponents. So the simplified form is 1 5/10 times 10 to the negative 6th power.
Right, and that's it. So if you were to multiply and the number that you get here is between 1 and 10, then you're finished. You'll be done. In this case, it wasn't, so we had to go ahead and write 15 in scientific notation and then simplify one step further. Now, let me back up and just remind you in all that we've done in these three problems. The reason that we can use the commutative and associative properties of multiplication is because that's all we have in this problem is multiplication. That means multiplication side by side with the parentheses. This means multiplication. If we run into addition or subtraction, that changes things completely. So right now we're just focusing on problems where we only have multiplication and we can rearrange order and grouping. Okay? All right, so now it's your turn.
Now it's your turn.
Here's your problem. Again, rearrange the order, change the grouping to group together the things that are common that you can simplify. And then make sure that once you've simplified it, the number that you have out front in your scientific notation is actually incorrect scientific notation form. Keep in mind that you have to have a number between 1 and 10, including 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and any decimal that you can come up with between there. So if your number is not between 1 and 10, then you need to go ahead further and simplify. Now the correct answer to this problem is B. And same thing in the last example, they multiplied 7 and 4, add your exponents on your base of 10, but then 28 is not in the correct form, so they had to go ahead and move it one decimal place, make it 2.8 times 10 to the first. All they're doing is just writing 28 in scientific notation. Then you have your times 10 to the 13th out there, and add your exponents one more time. All right, so make sure if you're not sure of scientific notation, go back and review that. That way when we get into multiplying them, it'll make it a lot easier for you.